Hey everybody, welcome back to Intermediate C++ Tutorial 18 Part 2. Today what I'm going to do is I'm going to show you one way in which inheritance can go bad and how we can fix that by using composition together with inheritance. Two great flavors that taste great together. And again, we're going to be working with the meme fighter code base, so let's get in on that. Alright, so this right here is the most fundamental scenario for polymorphism. Now what I want to do is show you something a little more advanced. So right now, all of our fighters, they all have the same attack. It's the punch attack, right? Not virtual, not doing anything. What I want to do is I want to give them different attacks based on, what weapon they have. So they could have their bare fists, but they could also have a knife or a bat. Now there's a couple of ways that we can approach this, and they are not all created equal. One way we could approach this is by using purely inheritance only solution. This is actually terrible, but bear with me for a second. So we've got our fighter, right? Abstract class. Now instead of the punch, we're going to give him an attack method, and it's going to be virtual, and it's going to be pure virtual. And then we're going to inherit from fighter three other abstract classes called fist fighter, bat fighter, and knife fighter, and they're going to override the attack with their own implementations. So the bat fighter is going to do a bat kind of attack, the fist fighter is going to do a fist kind of attack, etc. And then our actual concrete classes will inherit from these guys. So you can have a fist frog, you can have a bat frog, you can have a knife frog, you can have a fist stoner. Now look at this. This is terrible for a number of reasons. First of all, you're going to have an explosion of types with this kind of inheritance, because you're going to have, let's say you have 10 kinds of weapons and you have 10 kinds of fighters. That means in the end of the day, you're going to have 100 different concrete fighter types with the combination of weapon and fighter. That is terrible. The other thing here is if you look at like fist frog, bat frog, and knife frog, you're still going to have to implement their special. And their specials are going to be the same, so you're going to have to copy and paste that code here, here, and here, which we generally don't like to do. So remember when I told you that inheritance can be overused and you've got to be careful? Well, this is one of those. This is a perfect example of terrible inheritance design. You don't want to do this. Don't do this. So what's the solution? Well, the solution is very simple. Think about the idea of a fighter having a weapon. If a fighter is holding a knife, does that make him a knife fighter? Or is he just a fighter who happens to have a knife? The question there is it an inheritance hierarchy or is it a composition question? Is this fighter composed of the things that he has? Does he have a knife or does he have a bat? And in this situation, I would say that the weapon is definitely a better fit for composition. So we have the abstract fighter can have a pointer to a weapon class. Now, weapon itself is a good candidate for inheritance. We can have different kinds of weapons and they will have different behaviors. So the fighter has a pointer to an abstract base class weapon, and that is going to be pointing to some kind of concrete implementation, a fist, a knife, or a bat. It won't know which one it has. It doesn't have to know. All it will do is it will call the attack or whatever method of weapon, and that will be dynamically dispatched to the correct implementation of the child class of weapon. So this system here is much, much better. We don't have the explosion of types. If you have 10 kinds of fighters and 10 kinds of weapons, at the end of the day, you're going to have 20 kinds of concrete classes, not 100 times. Much, much better. So let's implement this design. This is composition and inheritance working together. So the basic behavior I want is fist is of course power plus 2d6, knife is going to be speed times 3 plus 3d6 damage, and bat is going to be power times 2 plus 1d6. So these weapons are going to have access to the attributes of the character in order to calculate the damage. Now normally I'd like to separate this up into different files, header files and CPP files, but we're going to do it all in a single file because that's what we've been doing up until this point. So attribute, we're going to make a struct of attributes, and that's going to be hit point, speed, and power. And now the meme fighter is just going to have a single attribute struct. We're going to fix up the meme fighter constructor like this, and we are going to add a function getAttributes that will get a const reference to the attribute struct that is embedded in the meme fighter. And this will give the weapon access to the attributes so it can read them and use them. Now, there are a lot of places where we have to change the access to the attributes. Now we got to go attr.hp. So we'll apply those fix-ups everywhere, like this. If I was doing more hardcore encapsulation, I wouldn't just expose these data members like this. I would give you public interface functions and make the data members private so that I could decouple the interface from the implementation. But for our purposes right now, this will be fine. Now, we want to create the weapon. So class weapon. Weapon is going to have two data members, the name of the weapon and the rank, because all weapons will have a name and a rank. Rank is going to be used to decide when a fighter kills another one, whether he should take that weapon. And public, so the interfaces are going to be the constructor of the weapon, the get name and the get rank getters, and the calculate damage, which is going to be virtual, pure virtual. It's going to take a reference to constant reference to some attributes, and it is going to give you the damage that that weapon will produce when it is used. And those functions are implemented simply like this. The pure virtual obviously doesn't have an implementation. Now we can, let's see here. Let's add weapon now to the meme fighter. So meme fighter is going to have a pointer to the weapon. P weapon. And we'll set that initially to null pointer, I guess. I don't know. We're making this private because I don't think the children will have to directly access this. I can give them a protected and public interface and they don't have to access it directly, but I might have to downgrade this to protected if necessary. Okay, so we got the pointer to weapon. Now the important thing here is that the punch is now going to be an attack. We're going to attack the other meme fighter. How do we do this? Well, we're going to apply damage to, and instead of calculating it statically like this, we're going to go P weapon pointer to calculate damage, and we have to pass it a reference to our attributes like this. Actually, we don't really even need this get attributes accessor because I don't think it's going to be necessary. I'm going to delete that for now. All right, so that was the only thing that changed here, but we also have to change the announcement. So we should say that name1 attacks other.name with his P weapon, that sounded weird, dot get name. Exclamation mark. There we go. That's a little better message. Apply damage. Everyone is maybe happy. I don't know, we'll see. Now let's add a couple of public interface functions. Number one is going to be void give weapon. And when we give weapon, we delete the weapon he's currently holding, and then we give him the new weapon. The other one is, of course, pilfer weapon. And this one will take a weapon away from the meme fighter if he has it. So what we'll do, we'll store the pointer in a temporary, and then we will set the weapon that the current guy has to null pointer because we pilfered, so he's no longer holding it, and then we will return the pointer that we had stored in the temporary. So you can give a weapon, you can take a weapon away. Now when a meme fighter dies, if he's holding a weapon, he should be freeing that. So let's not do default for the destructor. Let's motherfucking delete P weapon. You are responsible for a weapon if you're holding one. If it's null pointer, he's not holding a weapon, this will do nothing, so it's fine. And in the constructor, let's give the option of giving him a weapon to start off with, but we'll default that to null pointer. Initialize this pointer with this thing here. Very nice. So now meme fighter is weaponized. If I were a diligent chili, I would probably put a test in here to check to see if this is a null pointer before doing calculate damage, just as a sanity check, maybe an assert, but I'm not going to do it because I'm lazy right now. So meme fighter, so now it can have weapons. Now we actually have to make some weapons. So let's do it. Class fists public weapon. So we have to implement the calculate damage. So put that in here like this. And how do we calculate this? Well, it's fists is just going to be what we had before. So return attr.string.power plus, we also need the dice. So let's make a little change to the interface here. Calculate damage takes a reference to some dice. You take a reference to some dice. You return power plus d.roll, roll to. Is that better? Do you like it now? There we go. Okay, so there we go. We got calculate damage. Now this is going to necessitate attack, and you have to pass in the D. Give him the D. Yeah, okay, good. You like it? Good. You like the D. All right. So there we go. We got our calculate damage, and we also want to make our constructor for the fists. All fists are going to have the same name and the same rank, so we can just initialize that in the constructor for weapon. And there you go. There is one weapon implemented. Allow me to quickly implement the other two. So we got our knife and our bat implemented. Now let's give our dudes some weapons, shall we? So first of all, engage is not punch anymore. It is attack. So you shall attack. And I want to give my dudes some weapons. So for the constructor for Meme Frog and Meme Stoner, I'm going to give the option of passing in a pointer to a weapon. And in here, let's give these guys weapons. So now they have new fists, new bat, new knife, and let's see if this crashes horribly. There we go. Dat Boy attacks Scumbag Steve with his fists. Scumbag Steve attacks Dat Boy with his bat. Sweet as fark. Alright, now the last feature I want to implement here is the ability for one fighter to take the weapon of another fighter if he's dead and if the weapon is better. So, it turns out that with our composition system here, this is not very difficult to implement. First thing we're going to do is in Meme Fighter, we're going to add a couple of methods here. Has weapon to check if he has a weapon, and a get weapon method, which gets a const reference to weapons. It allows us to get information about the weapon any fighter is holding. So we got a couple of these const functions here, just information functions, and then we are going to implement this one here. Take is just a free function. Take weapon if dead. So it has takes two reference to taker and the giver. And what we're going to do is we're going to check to see if the taker is alive and if the giver is dead. And if the giver has a weapon, then we've passed the first stage. Now we want to check to see if the giver's weapon is better than the weapon that the taker already has. And if it is better, then we just print out a little message that the taker takes the weapon from the giver. And then we call giver.pilferWeapon. We get the pointer to the giver's weapon, and we set the giver's pointer to 0 with this function. So we get the weapon from the giver. We pass that to the taker. The taker replaces his current weapon with the giver, destroys his old weapon. And there you go. That's all you really need. And then in our engage function, after every attack, we also call a take weapon if dead. P1, P2, and then here P2 to P1. And do the same for do specials, because some specials have the chance to kill the opponent. So we want to give him the opportunity to take his weapon if that is available. And that's about it. Oh, here, I just fixed a little thing here. A little bit of copy and paste error. Now Team 2 can actually get a win message. So if we run this, so here we can see Dat Boy only has his fists, he attacks Scumbag Steve, and he takes his bat. And now it's the ultimate showdown between Pepe and Dat Boy. And now Dat Boy attacks with his bat, so we can see now that he has traded weapons and his next attack is actually using the bat. And he has used that bat to win the day. And there you go, Team 1 is victorious. An epic battle if there ever was one. And there we have another huge advantage of this composition plus inheritance system, because if we had just tried to do this with inheritance alone, it would not be so easy for one fighter to take the weapon of another, because you'd have to actually change into a completely different type. Here, all you do is you transfer the pointer of the weapon object and you're done. Much simpler, much more elegant, and much closer modeling to what would be happening in real life. All right, now I'm going to give you one more concrete real-world example of using inheritance and polymorphism and composition together to solve a problem. Now, in Project Twin, I'm currently working on a kind of prototype boss battle thing. And so the boss is going to have patterns, is going to have behaviors, and I'm going to model that with a state machine. It's going to have some virtual functions that are going to control the boss. And those virtual functions are going to vary depending on the type of behavior. And then you'll just swap out behaviors, transition from one behavior to another based on some kind of condition. And this is a super common pattern in games programming and programming, the AI of enemies and stuff like that. They're patterns of behavior. So what I've got simply here is just a template class behavior templated on the type of entity that it is providing the behavior for. And it's basically got a simple interface here, abstract interface that each of the specific behaviors will implement. So of course you got the virtual destructor, got to have that when you're using polymorphism. And then you've got two basic behavior functions here. The update, that's called every frame, that dictates the behavior of the entity. And this is also where one behavior might transition into another. And you've got the activate function, which is just called once when the behavior is first activated, do some kind of initialization stuff. And then I've got a whole bunch of different specific behaviors here. So for example, the Shia charge behavior, if I go into the implementation here, activation sets the direction and the speed of the boss and starts the boss moving. And then the update behavior here just checks for the condition of when to transition to the next state. And if that condition isn't set, then it just it sets the velocity of the boss, basically some kind of deceleration based on drag. Now, one problem with a finite state machine like this is you've got these fixed behavior states, and they are fixed to transition to another state depending on some condition. But in my situation, it's not quite that easy. Now, in my system, the boss is going to have different patterns of behavior, and those patterns are going to have common actions. So maybe you might have a pattern of charging the player, then shooting, and then a little pause. But you might have another pattern where you shoot, you spawn a little demon, and then you shoot again. So here, we've got the same shoot behavior here, but it has different transitions. So this isn't great. I would have to create two different classes. One is shoot into spawn, one shoot into wait. And that's annoying. I could also create, like a base shoot class and then inherit. One is, like shoot into spawn, and the other one is shoot into wait. But this is no good. This is, again, explosion of types. We don't like this. So what I do instead is I create my states, and the states have a state stack that is associated with them. And so I can stack up successor states. And what happens here is you do the charge. Then when this is time to transition, it will remove a state from the stack and transition to that state. And now this one has 2 on the stack. Then you're going to transition. When you transition here, you're going to remove another one from the stack, transition to that, and then you'll end. And when you hit some endpoint state, that state might make a decision to start a whole new chain and fill it up with another stack. So here, not full inheritance, some composition. States are composed of other states as part of their stack of states. And all the machinery, all that stock machinery that is required to manage the stack of states, that can all be inherited from behavior. So here in behavior, I am adding the vector, the pointer of the states in the stack. And I've got a few functions here that encapsulate and neatly wrap up the processes of managing the stack and the transition from one state onto another state. And here we see a whole bunch of different kinds of things going on here. We got inheritance of an interface going on here. Very simple situation. But we're also doing class inheritance, inheriting some concrete behavior. And what we're doing here is we are using composition instead of using extensive inheritance in order to simplify our problem here with a state pointer stack as opposed to an explosion of states, each one for each specific scenario of transitioning. But that's all I'm going to say about the behavior system right now. If you're interested in that, then you can look forward to that in a future video in the Project Twin series. I'll go into a lot more detail in that actual video. All right, and the last thing I want to talk about here is the performance impact of using virtual functions. A lot of people's ears just perked up right there. First off, if you use virtual functions in a class, all objects of that class will have to store a pointer. Doesn't matter how many virtual functions, have to store one pointer. And that pointer is being used to determine which functions are going to be called at runtime. Number two is because you need to use that pointer to determine which function is being called, you can't just directly jump to a function. You have to do a lookup, find out the address of the function that is to be called, and then you go there. So there's a little indirection. Those are the direct impacts, but one indirect impact that a lot of people overlook is the fact that because the compiler does not know which function will be called at runtime, it cannot inline any virtual functions that are actually being dynamically bound. And that's probably the biggest impact of using virtual functions. Now here's the big takeaway from this. This is the most important thing I'm going to say here, and that is 99% of the time, this difference in performance isn't going to mean shit. So if you're worrying about it, and if you're using suboptimal constructions because you want to avoid that virtual function cost, I'm wasting cycles with these virtual function calls, you are motherfucking being a retard. That's what I'm going to say right here. There are cases where it will matter, but they are very rare. And oftentimes what you see beginners doing is they're going to think that everything they do is a big performance impacting thing, and it's not. Let me give you an example of one thing where the performance actually matters. In the sprite effect system, where we use functors and they handle the different effects on the put pixel, transparency, and so forth. In that situation, you are going to be hammering that functor maybe millions of times per second. And in that case, yes, there would actually be an impact if you used virtual function calls instead of functors. In that situation, virtual function calls would be nicer because you could swap out different effects dynamically at runtime. You can't do that with functors, but I will still use functors in that situation because the cost of, millions and millions of virtual function calls versus millions and millions of inlined functor calls is actually substantial. But it's a very rare case. Ask yourself this question: am I going to be calling this function, millions of times per second? If not, maybe I should just use a motherfucking virtual function call. Remember, the only thing worse than a premature ejaculator is a premature optimizer. And that's going to about do it for this video. Today, my main goal was to show you some bad patterns, some bad designs with inheritance, the idea of using only inheritance to try to solve a problem, and then how much better it looks when we try to use composition together with inheritance. I also want you to note the system that we ended up going with. We've got a vector of a bunch of different meme fighters. We don't know what kinds of meme fighters they are. Those meme fighters are holding weapons, and again, they don't know what kind of weapons they're holding, but it doesn't matter. This whole system works without having to know the concrete types of anything. Everything gets taken care of through polymorphism and dynamic dispatch, and that is the kind of design that I really want you to be striving for. In the next video, I am going to show you how you can discover the actual types that your polymorphic pointers are pointing to. But even though I'm going to show you this, it is really only a last resort. And again, if you want to see more examples of this polymorphic design stuff, in the Twin series, Project Twin, starting from about tutorial 13, I'm going to start integrating this stuff into the Twin engine, and you're going to see a lot of different places where this is used. So if you're interested in seeing examples of concrete design implementations, then you can take a look at Project Twin, starting from about episode 13. Anyways, thanks for watching. Hope you enjoyed the video. If you did, please click the like button. It helps a lot. And I will see you soon with some more C++.